From 2016 to 2019, meteorologists saw record-breaking heat waves around the globe, rampant wildfires in California and Australia, and the longest run of Category 5 tropical cyclones on record. The number of extreme weather events has been increasing for the last 40 years, and current predictions suggest that trend will continue. But are these natural disasters simply bad weather, or are they due to our changing climate? To answer this question, we need to understand the differences between weather and climate, what they are, how we predict them, and what those predictions can tell us. Meteorologists define weather as the conditions of the atmosphere at a particular time and place. Currently, researchers can predict a region's weather for the next week with roughly 80% accuracy. Climate describes a region's average atmospheric conditions over periods of a month or more. Climate predictions can forecast average temperatures for decades to come, but they can't tell us what specific weather events to expect. These two types of predictions give us such different information because they're based on different data. To forecast weather, meteorologists need to measure the atmosphere's initial conditions. These are the current levels of precipitation, air pressure, humidity, wind speed, and wind direction that determine a region's weather. Twice every day, meteorologists from over 800 stations around the globe release balloons into the atmosphere. These balloons carry instruments called radiosondes, which measure initial conditions and transmit their findings to international weather centers. Meteorologists then run the data through predictive physics models that generate the final weather forecast. Unfortunately, there's something stopping this global web of data from producing a perfect prediction. Weather is a fundamentally chaotic system. This means it's incredibly sensitive and impossible to perfectly forecast without absolute knowledge of all the system's elements. In a period of just 10 days, even incredibly small disturbances can massively impact atmospheric conditions, making it impossible to reliably predict weather beyond 2 weeks. Climate prediction, on the other hand, is far less turbulent. This is partly because a region's climate is, by definition, the average of all its weather data, but also because climate forecasts ignore what's currently happening in the atmosphere and focus on the range of what could happen. These parameters are known as boundary conditions, and as their name suggests, they act as constraints on climate and weather. One example of a boundary condition is solar radiation. By analyzing the precise distance and angle between a location and the sun, we can determine the amount of heat that area will receive. And since we know how the sun behaves throughout the year, we can accurately predict its effects on temperature. Averaged across years of data, this reveals periodic patterns, including seasons. Most boundary conditions have well-defined values that change slowly, if at all. This allows researchers to reliably predict climate years into the future. But here's where it gets tricky. Even the slightest change in these boundary conditions represents a much larger shift for the chaotic weather system. For example, Earth's surface temperature has warmed by almost 1 degree Celsius over the last 150 years. This might seem like a minor shift, but this 1 degree change has added the energy equivalent of roughly 1 million nuclear warheads into the atmosphere. This massive surge of energy has already led to a dramatic increase in the number of heat waves, droughts, and storm surges. So, is the increase in extreme weather due to random chance or changing climate? The answer is that while weather will always be a chaotic system, shifts in our climate do increase the likelihood of extreme weather events. Scientists are in near universal agreement that our climate is changing, and that human activity is accelerating those changes. But fortunately, we can identify what human behaviors are impacting the climate most by tracking which boundary conditions are shifting. So even though next month's weather might always be a mystery, we can work together to protect the climate for centuries to come. So what kind of solutions to the climate crisis are people working on? How about underwater farming? Certain crops could actually help clean the oceans while drawing carbon down from the atmosphere. Or how about new energy sources? Here's what a world run entirely on renewable energy sources would look like.